Mathematics 1, January 2016 exam. Question 6. Sketch the following curves on the same set of axes. Let's start by drawing a grid of the values of the quadratic. When x equals 0, y is equal to minus 5. When x equals 1, that's going to be 2 minus 3, so that's minus 1. Minus 1 and minus 5 is minus 6. When x equals 2, 2 squared is 4 times 2 is 8. 8 minus 6 is going to give us 2. 2 minus 5 gives us minus 3. When x equals 3, 3 squared is 9. 2 nines are 18. 18 minus 9 is 9. 9 minus 5 is plus 4. X equals minus 1, that's going to be 2. That's going to be 5, so we're going to get a 0. And when x equals minus 2, that's going to be 8. And that's going to be 6, and 8 are 14. Minus 5 is going to be plus 9. So we've got the curve that goes from a positive value through 0 to a negative value and then back to a positive value. And when we sketch that, it'll look like this. As far as the straight line is concerned, the quickest way to do that is to say when x equals 0, y equals 10. X equals 0, y is 10, so we can put a point there. And then when y equals 0, 4x equals 10, so x is equal to 2.5, which is that point there. And then we can draw the straight line. So that's parts A and B. Calculate the intersection of the two curves. We know that y is equal to 2x squared minus 3x minus 5, and also that y is equal to minus 4x plus 10. And because both of these are equal to y, that means they're equal to each other. So taking the 4x onto this side, it becomes plus 4x minus 3x gives us x, plus 10 onto the left hand side becomes minus 10, so that gives us minus 15x. So now we need to factorize this quadratic, so we'll see if we can factorize the quadratic by inspection. So we'll put a 2x in there and an x in here. Factors of 15 are 3 and 5, and we want a difference of 1. So if I put a 3 in here and a 5 in here, 2x times 3 will give me 6x, and then 5 times x will give me 5x. So this needs to be a positive quantity, this needs to be a negative quantity. So just check that. We've got 2x times x, which is 2x squared, 2x times 3, which is 6x, minus 5 times x, which is minus 5x, so we get a net of x, and then we've got minus 5 times plus 3 is minus 15. So that means the two factors of x are x plus 3 is equal to 0, so x equals minus 3, and 2x minus 5 equals 0, so x is equal to 5 over 2. Substitute those into the linear equation, put in the minus 3 here, so I'm going to get minus 4 times minus 3 is plus 12, plus 12 plus 10 is 22, and when x equals 5 over 2, 5 over 2 times minus 4 is going to give me minus 10 plus 10, so y is going to be 0. So the values of y are 22 and 0, which means the points of intersection are minus 3 and 22, and 5 over 2 and 0. Part D. How do you know the two points of intersection are correct? Well, we put these values of x into the linear equation. For part D, I'm going to put them into the quadratic equation. So when x equals minus 3, minus 3 squared is 9, 2 nines are 18, 3 times minus 3 is plus 9, so 18 plus 9 is 27. 27 minus 5 is going to give me 22, which agrees with that, so that's correct. And when x equals 5 over 2, 5 over 2 squared is going to be 25 over 4, that'll be 25 over 2, times x squared is going to be 25 over 4, the 2 will cancel, so that will be 25 over 2. Put x equals 5 over 2 into here, so we're going to get 15 over 2. 25 minus 15 is 10 over 2, which is 5. 5 minus 5 is 0, so that agrees with that. So we are sure that our points of intersection are correct, and just whilst we're here, there they are on the graph.